Now that we've seen that the log can be an important function, we're going to apply it to the likelihood and show that we're going to have to express in terms of the log likelihood to compute our gradients. This continues to be part of that very, very optional PhD level only derivation that we're doing here. Now let's revisit the likelihood function that we discussed and see how the log plays a role. So the key here is that the log of the sum is the sum of the logs that we discussed. And in our case, if you have the log of the product of I equals 1 through n of some function, let's call it fi, then that is equal to the sum over I equals 1 through n of the log of fi's. So the log of the product is the sum of the logs. And so in our case, what we're going to get is that the log likelihood function is going to be the sum over I equals 1 through n of the log of the probability of yi given xi and w. Now, if you're thinking about derivatives, you'll see exactly why the log was useful. The log of the derivative of a product is really a complicated thing. But once we've taken the log, the derivative of the sum is just the sum of the derivatives. And so that's going to simplify all the math that we have to do. And that's the core reason that we take the log. There's a few other technical reasons, but that's one very important one. Okay, so that was trick number 1, take the log. Trick number 2 is to introduce indicator functions, just like we showed in the derivative that we had before. So if we take the log likelihood function, so this is the sum of the log of the probability of yi given xi and w, that can be written as the sum of two terms. The indicator that yi is plus 1 times the probability of yi equals plus 1, plus the indicator of y is minus 1 times the probability of y equals minus 1. So in other words, if yi is plus 1, then the first term comes to play and the second term becomes 0. But if yi is equal to minus 1, then the first term becomes 0, then the second term becomes active. And so we see that because of this, we get exactly the equation above, but the indicators are going to make our life a lot simpler throughout the derivatives and all the operations that we need to do. Here's an interesting thing. In our, so far, we've only talked about the probability y equals plus 1, but in this equation we have the probability y equals minus 1. Interesting.